Onto the exercises. Using its constructor, create a series containing three two-item lists of integers. Okay, let's try that. Three two-item lists. So this will be kind of tricky. So 1, 2, 3, 4, just maybe a different one, 9, 10. All right, so this is not something common to do, but just to show you, you can put anything in a series. Call dot sum on this. Let's see what happens. Is it going to just concatenate all these lists together into a single one? Well, it does. So pretty interesting. So this is possible. There might be some unique situation where this does occur, and you can use the methods just as normal on them. All right, number 2, use the constructor to create a series of integers, floats, and booleans. Do not set the d-type parameter. Okay. So let's put, let's see. All right, so we put multiple different types and actually preserves the original type using the object. So again, object can contain any of these. It doesn't just convert them all to floats. It keeps them as they are, but uses the object data type. So interesting. Not that you necessarily will do this, but just to kind of experiment and see what Pandas does with different inputs. Number 3, construct a series with the same values, but force the data type to be a float. Does it work? So let's go ahead and do this and say d type equals float 64. So it does work. It does convert true to 1.0, right? 5 is still the same, and 3.4. So it just forces that conversion. Number 4, construct a series containing 3 strings and the 4 missing values. Okay, let's do that. pd.series. So 3 strings. So sum Python strings, and then all of these missing values. So none. These are all different possible missing values in Python. pd.na, pd.nat. This is not a time. Okay, let's do these. Assigning the result to a variable. Let's call it s. All right. All right. Using pandas, count the number of missing values in exercise 4. s.isNA. So it does correctly do that. Okay, good. So notice here it does preserve those missing values, but Pandas is able to correctly identify each one of them. Number 6, convert the series from exercise 4 to the new string data type. Okay, so this is interesting. What is going to happen here as type string? And we see that it just uses the pd.na for all of its missing values. So this is actually another nice feature, is that the new Pandas data types have a single representation for a missing value, not all of these other ones. All right, so we're going to read in the first 10 columns of the movie data set over here, putting the title in the index. Which of these columns above are good candidates for categorical? Okay, so let's look through here. Looks like actually most of them are. So year could be, categorical for sure. It isn't numeric, but it is could be a category. It's distinct. There's not too many years of movies. Color, yes. Content rating, very likely. Director name, there are a lot of director names. Same thing with actors and actresses, but those could also be categorical. So I would say all of those. Number 8, select the content rating as a series and convert it to categorical. All right, let's do that. Content rating as type category, like this. Assign the result to rating. All right, let's do that. Run an expression that returns the number of categories. Okay, so rating.cat.categories, that's the number, do length of that. So there are 18 categories. Prove that the str accessor still works with categorical columns by making the ratings lowercase. So even though it's categorical, it still is able to work with categories like this. So we can call the lower method from the str. Number 11, assign the rating GGG as the first value. So the very first value we can do in a number of ways. That iloc. If we try to do GGG, that's not going to work. We have to do rating.cat.add categories. So we can add this category and reassign it to rating. And then we can do the same thing, iloc like this, ggg, and we can check it. So we created a new category and now assigned it to one of the values. Convert the following series to integer. So s.asType int, let's do int 8. There's only a couple values there. Convert the following series to integer. If we try to do the same thing, we're going to get an error. What we need to do is do pd.toNumeric and do s and say errors equals coerce. This will make this nan. This is still not integer. So what we could do is do .asType int 8. So nullable integer like that. Are reading the diamonds data set. Select the cut column as a series and convert it to ordered categorical. So we have to use the data dictionary up from that we read in above. So it's up here. We go back up over here. So cut. So here are the categories in order from least to best. Let's go down. So again, we do cats equals and convert them to strings. Okay. Those are the categories. And we will say pd.categorical dtype cats, say ordered equal to true. And then select the cut column to convert it ordered categorical. So we need to assign this. This is the this is just the D type. I'll just call it category. All right, so now I'm ready to do this. So diamonds cut that as type category. So it's just this variable called category, and I'll call it cut cat equals this, and it's just look at this cut cat dot head. All right, so it's ordered, and it's a series of all those values. By only knowing that cut cat is ordered categorical, write an expression to get the percentage of diamonds that have the lowest category. Okay, so we need to find the lowest category, so that's fair. We say cut cat equals the minimum. How often is it the minimum? And then we just do, this is a Boolean series, and we just do dot mean, and this will be the percentage when we multiply by 100. So about 3% of the values are the minimum one. Another way of doing this is just do value counts and do normalize equals true, and then we can sort the index. That'll get it lowest to high, and then we get the very first one like that. All right, great. So that is number 15, and that is all of the exercises.